National Technical Campus, Faculty of Engineering and MBA. Today, in Power Electronics, next lecture, we learn the VI characteristics of SCR. VI characteristics of SCR. SCR is nothing but silicon controlled rectifier, and its VI characteristics is nothing but voltage versus current characteristics. First of all, I will draw the diagram for VI characteristics, or we can say that I will draw the graph for VI characteristics. Here, x-axis and y-axis. On x-axis, voltage is there. Voltage is in between anode to cathode, and on y-axis current is there, that is the anode current. Now we know in SCR there will be three terminals: anode, cathode and gate. Here this is for Ig is equal to 0, or Ig1, Ig2 and Ig3, that is the gate current. Here breakover voltage is there, and before this breakover voltage, this region is called as a forward, or this state is called as a forward blocking state. Forward blocking state. Now this dotted line is called as a transition state. Transition state. And this current, which is very high, and in this case SCR is in on state, called as a on state. Now here this current is called as a holding current, and this is the latching current. Latching current is always higher than holding current. These characteristics are called as a forward characteristics. Forward characteristics. And here called as a reverse characteristics. Reverse characteristics. In reverse characteristics of the SCR are same as that of the diode. I will draw the reverse characteristics. This is the reverse breakover voltage, and very small amount of current flow called as a I0, or this current is called as a reverse saturation current, and also called as a leakage current. Reverse saturation current is also called as a leakage current, which is very flow in very small amount. Now I will explain these characteristics again. See, first of all, this why it is called as a VI characteristics, because it is the graph of voltage versus current. Hence, it is called as a VI characteristics of the SCR. As voltage is present, which is in between anode to cathode, hence named it as a VAK. And current flowing through SCR is the anode current, which flow from anode to cathode, hence called it as a anode current. These characteristics divided into two parts. First part is forward characteristics, and second part is reverse characteristics. These reverse characteristics are same as that of the diode. No any change will be there. Hence, these are same. I will explain only forward characteristics because these are learned already in diode. Now see forward characteristics. Again, these forward characteristics divided into step is forward blocking step. Second step is transition step. And third step is on step. Now see one by one. First is forward blocking step. This forward blocking step is shown here. Here, forward blocking step. Forward blocking step means the applied voltage is smaller than breakover voltage, and in this case your SCR is in off condition. See here, applied voltage means VAK is smaller than breakover voltage. This is the breakover voltage. Applied voltage is smaller than breakover voltage. In this case, SCR is in off condition. Hence, this state is called as a forward blocking state. This is high voltage, low current state. See here, voltage is from this to this. Voltage is very high, but current flowing through this is very small. Very small amount of current flows through this. This is the forward blocking state. Second state is a transition state. This transition state is shown by dotted line. Here, dotted line is present. This dotted line indicates the transition state, and this transition state is present in between forward blocking state and on state. This is an unstable state because we cannot predict the time required for this transition state. It totally depends on the gate current or gate pulse provided to SCR. When gate pulse is very high, at that time transition time required or transition time is very small. Means transition state is very small. And when your gate current is very low, or we can say that when no gate pulse is provided, at that time required for SCR is very high. Means transition state becomes very high. It is an unstable state, totally depend on the gate current and present between forward blocking state and on state. Now, third one state is the on state. This on state is present here. In this state, we can say that it is a low voltage, high current state because in this case, very small amount of voltage is present, but current is very high. Hence, in this state, we can say that it is a low voltage, high current state, and in this state, your SCR goes in on condition. Means SCR get turned on in this state. These are the three states. And next one point is, here we apply the gate pulse. I can say that the IG 0 means no gate pulse is there, is always less than IG1, is less than IG2, is less than IG3. What can I will say from this? See here, as IG0 is less than IG1, less than IG2, less than IG3. Means observe here, when IG is equal to 0, in this case, breakover voltage is very high. As IG goes on increasing, means here I will increase the value of IG. At that time, breakover voltage goes on decreasing. See here, when IG is equal to 0, breakover voltage is very high. When IG goes on increasing, breakover voltage goes on decreasing. Again, IG2 is high than the IG1 or IG0. At that time, breakover voltage also goes on decreasing. Again, IG3 is higher than IG2, higher than IG1, higher than IG0. At that time, breakover voltage also goes on decreasing. From this, we conclude that by increasing gate current, breakover voltage goes on decreasing. Now, latching current. Now, what is the holding current and what is the latching current? This holding current is the minimum amount of current that can flow through the SCR and hold the SCR in on state. And latching current is the minimum amount of current flow through the SCR and latch the SCR in on state. Now, in both the case, from definition we can understand, in both the case SCR is in on condition. Now, what is the difference between holding and latching current? Holding current hold the SCR in on condition. Latching current latch the SCR in on condition. Second difference is your latching current is always higher than holding current. And third difference is when your current goes below the holding current. In this case, SCR gate turned off. But when your current goes below the latching current, SCR remains in the on condition. It does not turn off. This is the basic difference between holding current and latching current. Now, see breakover voltage. This VBO is called as a breakover voltage. Now, what is the breakover voltage? Breakover voltage is nothing but the voltage below that SCR is in off condition. And when your applied voltage is greater than this breakover voltage, then SCR goes in on condition. In other words, this breakover voltage is also called as a threshold voltage. This is the threshold value required for the turning of the SCR. These are the VI characteristics. Now, what are the advantages of the SCR? Basically, your SCR is a high current, high voltage and high power handling device. Means in industrial purpose where we need to handle the high power, high current and high voltage. At that time we use the SCR, and also it is used for as a switch when we require automatic switch. In this case also SCR is used. Then next one is disadvantage. Its main disadvantage is its turning on process is very simple, but to turn off the SCR we need extra circuitry. We can say that SCR turn on method is very simple, means it's the one of the advantage of it. But its disadvantage is to turn off the SCR we need extra circuitry. We call it as a commutated techniques or commutated methods are required for turning of the SCR. Means we can use class A, class B, class C, class D, class E and class F are the commutated techniques used for turning of the SCR. Now, the next point is SCR is a unidirectional device. Means current flows only in one direction, not in both the directions. This is one disadvantage of it. And last point is applications. It is used in level controller, also temperature controller, in battery charger, burglar alarm system, emergency light system, etc. are the applications. AC or DC circuit breaker, etc. are the applications of the SCR. Thank you.